Okay, so if a baseball is thrown into the air, the function has negative 16t squared. That makes it a parabola that's upside down. And the 6 is the starting height. So that means when the person releases it, it's 6 feet off the ground. And then the ball's going to go up, and then of course gravity is going to pull it back down, and it's going to hit the ground. So for the domain, that means what are the possible t values? Well, at the beginning, that would be t equals 0 seconds. And then we'll need to use the quadratic formula to find out what is this t value. And then that's going to be the domain from there to there. And then also, if we find out where the maximum is, that will tell us the maximum height. So that's going to help us find the range. But first, the quadratic formula. So we've got a equals a negative 16, b equals a 50, and c equals a 6. And then use the quadratic formula. We could do complete the square if we wanted extra work, but quadratic formula is going to be a little bit faster. So this has the variable t, so it's going to be t equals negative b plus or minus the square root. The b gets squared minus 4 times a, which is negative 16, and then c, which is 6. And the whole thing is divided by 2 times a. And then it's time to use a calculator and see what that equals. So then I just need to open the calculator app and all right, I do need parentheses, and then negative 50 plus the square root, and then 50 is squared. Oops, that's not squared. There's 50 is squared, minus 4 times a, which was negative 16, times c, which is a 6, and then it's divided. So I need to put parentheses, so the whole thing gets divided by 2 times negative 16, so that means we're dividing by negative 32. And that is time equals a negative. That's not possible. So do the quadratic formula again. This time put the minus, and then it's 3.241. So that's how many seconds it took for the baseball to hit the ground. So then I can say that this one is 3.241. And so that's going to be the domain. So the domain, and I'm going to write it in interval notation. It goes from 0 seconds to 3.241 seconds. And then I actually put the square bracket because that is the moment that it hits the ground. So that actually does exist. All right, that's the domain. Then for finding the maximum, there's several ways to do that. The easiest and fastest way is right here. T is going to equal negative b divided by 2a, which is actually this part of the quadratic formula. So basically, to find out the maximum, you just don't do the square root part, and that's going to tell us when the maximum occurs. Okay, so for the maximum, t will equal negative 50 divided by negative 32. So just those blue ones that I have circled. And then that equals, so 50 divided by 32. So rather than switching the calculator, I'm just going to do that on a calculator on the side. So that equals 1.5625 seconds. And then you can just substitute that into the function and find out what the height is. And so if we go back to the graphing calculator, we could also graph it and verify all of this all at once. So it was negative 16x squared plus 50x plus 6. And then there's the parabola that I was talking about. So for one thing, we should get 3.241. That's correct. And then also for the maximum, since I have a touch screen, I can just go like this and find out the t equals 1.563 and the height equals 45.062. If you don't have a touch screen, you can go to second calculate and then trace. And from the negative b over 2a, we got 1.5625 if I want to put all the decimals. And then it says, so the maximum value is 45.062. So then the height, maximum height was a 45.062 feet. And then for the range, so that basically means you go up to a height of 45.062 feet, and then on the bottom, that would be 0 feet. So from 0 to the 45.62. So I did say find the maximum, so that's part of the answer. The domain is part of the answer, and then the range is the last part of the answer. So that goes from 0 feet to 45.062 feet.